good?
Good.
What section is this?
36.3.
36.3, okay. This is called an exponential growth curve. And if you look at the growth of the human population, it looks exactly like this. The human population, just in the last 100 years, has gone from 1 billion to, what are we at now, 8 billion? 7.5 billion?
I think it's
7.7 billion?
7.604 billion.
When I was your age, it was 4 billion. I remember learning that in school. 4 billion people. I was like, wow. So it's almost doubled since I was your age.
That's scary.
Now, the thing about exponential growth is, it can get, look at the steepness of this curve. It can go up really fast. And so, you say, oh, it went up 2 billion from my age to your age. If it continues that from your age to my age, it's not going to go up another 2 billion. It's going to go up 4 billion. And we'll have added the same amount of people that were on the earth when I was your age. We'll have added that to the population from the time you get older to my age. That's a lot of people to put extra on the. That's twice the people from when I was a kid, and it's actually more than that. Wow, that would be 12 billion people. It's already pretty crowded, isn't it?
Pretty bad.
Yeah.
It's good for real estate. You could be a realtor.
Until society collapses.
But that's not what usually happens with a population. A population will do that if it has room and space and plenty of resources, but that will always have to stop. You'll run out of resources. And so what you'll see a population do is it starts low. We call this the lag phase. It goes through a little lag phase. Let's see if that doesn't show that. Anyway, it's like a lag phase where it kind of starts slow, and then it really gets going. This is the exponential growth phase. But then it starts to level out because the organisms start to run out of space and start to run out of food. And what we say is they run into limiting factors. They run into some factor that limits their growth. Maybe they don't have enough space. If you're talking about bacteria on a dish, they'll run out of space. They start living on top of each other. That's what we're doing. That's what humans are doing. We're starting to run out of space. We're starting to live on top of each other, aren't we? Literally, in a building, you're on top of each other. The cavemen didn't have buildings. They could spread out. On a lab dish, the bacteria will not have enough food because there are other bacteria around it eating the food that's near it. And so they run out of food. And then their wastes. They start producing wastes. And the waste they produce can drown the bacteria next to them. Drowning and dying in waste. Wouldn't that be bad if you were humans, drowning and dying in waste?
Yeah.
That's exactly what's happening. That's called pollution. You ever heard of pollution before? That's drowning and dying in our own wastes. Cavemen didn't have to deal with that. They just threw their crap out in the woods. You throw your crap out in the woods now, there's somebody in the woods. It's their woods. They're not. Somebody's living there. Yeah, there's people in the woods.
What are you doing in my woods?
So the population will level out. It'll come to a deceleration phase. Right about here, it decelerates the growth. And then it completely levels out.
That's pretty cool.
And you can see an awesome example of this if you look at the coronavirus growth. Let me just show you real here. Coronavirus. Let's do worldometer. You want to do worldometer?
Yeah.
Worldometer has good graphs. This shows the deaths of coronavirus. It's up to about 3 million. Daily new cases, daily deaths. Let's just get the U.S. You want to get the U.S.?
Let's get the U.S.
How do we get
That's
this?
all the time presenting things.
Oh, here we go. U.S. We're the leader.
Yeah!
number one.
Why are we like this?
Oh, Georgia.
And you can see what happened yesterday. Keep track of this. 1,400 deaths.
California number one.
At the bottom.
Who's last?
Probably like
Okay, take a
California or
look at
Colorado.
this. So, you can see exponential growth right here going on. Doesn't that look like kind of a J-shaped curve?
Oh, absolutely.
Here.
And then it levels out, and then it started going down.
Yay, we're going down.
Spring break.
Yeah, and the weather has something to do with it. The virus does better in the cold. We're inside. We keep the windows closed. We share each other's air.
Yummy.
But you can see, and there was actually the same sort of growth at the beginning. Will it give us a close-up at the beginning here?
The state with the least cases is Vermont.
I don't know.
Yeah.
Oh, only 28,000 cases. Oh no,
Vermont
18,000.
has the lowest
It's
number of
also a really
cases.
small state.
That's crazy.
How is Rhode Island
Even
higher?
Washington
Total
D.C. has
cases.
more
Look at Rhode Island.
And
compared
Look,
to
Georgia's
us. How many
sick.
does Georgia have?
Yeah.
California,
Georgia had
3,600,000
over a million.
cases.
Yeah.
Yeah.
But how does Rhode Island have over 100,000?
California. I mean, California.
Do that
basically
people?
all west
Do
coast.
that many people even exist in Rhode
So
Island?
that's to be
absolutely.
expected. It's
It's very
the
prevalent.
biggest state in
I
population.
went to visit my cousin once.
So the bigger
Ooh.
states in
It's
population
in
have the
Frederica
bigger
as a
deaths.
state.
That makes
Oh dear God.
That's what I said. I booted out of there.
So anyway,
Oh, let's look at
that's
Florida.
high too. You can
Florida?
check that's
I
the
imagine
world over
Florida's
here.
kind
If
of
you want to
Number
check up on
Oh,
it.
2 million.
We expect it to go down. Why would the coronavirus go down? Well,
It needs living people.
Herd immunity, vaccine.
for a virus to cause disease, it needs a new person who has had the virus before. And so the reason why it goes down is it runs out of new people to infect. If you've already had it, you're probably not going to be able to get infected from it. They don't know that for sure with this virus, but that's usually the way viruses work. That's why vaccines, people are getting vaccinated now. Something like 20% of the country has had one shot now. There's 20% of your possible food gone for the virus. So the virus numbers are going to go down as more people catch the disease and more people get infected. Vaccinated. So you always see it. This is called a logistic growth curve, where it goes up and then levels out. And here is, there's some famous graphs. They often put them on tests and things showing, here's the growth of yeasts that was done in a controlled experiment. And you can see they just went up real fast and then they level out as soon as they run out of room in the test tube, run out of food. And this dotted line you see here, the populations reach. Ooh, look at these seals.
Leopard seals.
They introduced seals, and there were about 1,500 of them, or they started counting seals in 1975? And they did well. I think that was the year they had the Marine Mammal Protection Act, where you could no longer hunt them, and it was illegal. So their numbers did really well after no one could hunt them, but it won't go on like that forever. It'll eventually level out. There's only a certain amount of seals that an area can support. So what is that number? That's called the carrying capacity. This dotted line is called the carrying capacity, and you always level out around the carrying capacity. The carrying capacity is known as K if you're doing these math problems, which we're about to do. Do some math. Did you bring your calculators?
Yep.
Absolutely.
Populations level out of the carrying capacity. Now, do y'all remember what K-selected creatures versus R-selected or populations? Y'all know what that means?
K-selected is have a few offspring and look after them closely.
Right. Now, if you're K-selected, like these seals, you have a few offspring, you take good care of them, you try to make it so most of your offspring survive. And what K-selected creatures tend to do, if you look at their population sizes, is they increase then they get to the carrying capacity, and their levels tend to stay around the carrying capacity. Now, their levels can change if the carrying capacity changes. If suddenly there's a lot more food comes to the area somehow, then their levels will go up. If suddenly there's a lot less food in the area for some reason, their levels will go down. But they tend to stay around the carrying capacity. Yeah. Yes. Just because you won the fair.
Thank you. Yeah.
So we haven't reached our carrying.
Humans have not.
Just a matter of time.
We're still like this. Actually, scientists have started to detect a small lessening of the curve. And we don't know where it'll end. What's that?
We need a purge or something.
China instituted heavy taxes if you have more than one kid. And that really worked well for them to lower their population.
They just like
We should all
But what ended up happening is, because you could only have one kid, the parents wanted males, so there was a big problem. Now there's too many males.
Yeah, just get rid of the females.
If you've ever been to a bar that has too many males, it's not a fun place.
What happens when there's too many males at Ziggy's?
It's not good. Get out, right? Get out. It's a
Dance battle.
dance contest, bro. Me and you.
What was this movie called?
What?
You did that or something.
Oh, the.
What was that?
Oh, you did. It was like.
I don't remember.
Is it DNA?
Or,
Wax
It was
on,
the
wax off.
anti-parallel.
no.
Yeah.
Yeah.
Okay.
Oh, it was DNA.
Yeah.
Parallel versus anti-parallel.
Heck yeah.
I don't know that.
Oh,
Gotta take them out.
oh.
That's where they step off the floor.
Absolutely.
Hit it, I guess.
Take notes.
So you can see these are some worms here. If the worms have a low population density, they'll lay a lot more eggs. If the worms have a high population density, they'll lay much fewer eggs. So there's something about the worm's biology that says don't lay a lot of eggs if there's a lot of worms around. Probably the kids wouldn't survive, right? There's too much competition for food from the larvae. So, ooh,
Is that fungus?
that's a bat. Has it got fungus
Is
on
that
its face?
fungus?
Yeah, it's got some fungus on its face.
Ew.
Let's
It's just allergy.
Turn around.
let's do some problems.
Poor baby.
So I got a problem sheet. Let's go.
I'm so excited.
And
Oh, that's fun.
here, pass this around. Take
I'm
one,
waiting
pass,
for this problem
take one,
sheet.
pass it around. Take one, pass it around. And let me
Oh.
pull this up on the computer. And we got all day tomorrow to work on this
We
too.
were really vibing in
We're gonna have a
February.
quiz over this section tomorrow. You just had to say it. So, if you go to AP Biology Problem Sheet. No, AP Biology Equation.
Can't we vibing in February? It's fun.
Have you ever seen the AP Biology Equation Sheet?
Yep.
Of course.
It's on our exam. So good.
Exciting.
Okay, take a look at this. So here's the equation sheet, and there's chi-square. You know, did we do chi-square yet?
Yes.
And standard deviation, standard error.
Absolutely.
We've done a bunch of these. Go to the second page. Look at this. Rate and growth. All these equations here are population problems.
Oh no.
Everything here. We did water potential already. Remember that? Y'all don't remember?
I
water
remember
potential?
that.
I do.
The little side, pressure potential, side potential. We'll go back over these before the exam. Ooh, we haven't done systems diversity index yet.
Ooh.
Okay, so let's look at population problems. So, kind of in my experience, the best way to learn to teach these is just to do some sample problems. So let's look at the first problem. In a lot of these, you can just do, just using your brain. You don't have to use the equations for everything. I think the first one is a good example of one where you wouldn't have to know all the equations to do it. Number one, there are 2,000 mice living in a field. 1,000 mice are born each month, and 200 mice die each month. For 1 month, what is the net population growth? Can you do that without looking at a formula? Think about it for a minute. Don't yell it out. Use your brain. If 1,000 mice are born and 200 mice die, how many new mice do you get?
800.
800.
800.
Yeah.
1,000 are born, 200 die. That's 800 new mice, right? Did you need a formula for that? Well, they got one for that. Look at the population growth formula. Y'all, on the screen. Look at that population growth formula. dn/dt. First, you have to understand what dn/dt means. dn/dt is the change in the population number over the change in time. Have y'all seen that dn, that sort of thing in math before? Maybe, I don't know, are y'all in pre-cal, or some of y'all might do this kind of thing? No?
We do in Cal.
Y'all seen like,
What are we doing, Kelly?
Yeah, it's DNGT.
y'all seen things like dn/dt?
Unfortunately, I
Isn't that derivative?
Yes, that's a derivative.
So-
Calculus.
This means, the D means the change in. The change in N is the number of the population. N equals population size. How do I know that? From looking at the equation sheet?
Can we write on this paper?
Yes. Look, N equals population size. So, dt means change in time. dy, it says, means amount of change. The rate is the amount of change over the change in time. So, what happens when a population changes size? It changes its number of organisms over a certain amount of time. In this question, it changed. What was the time period involved?
A month.
A month. So the number of organisms changed over a month. That's all this fraction means. You'll see this fraction and it'll make you want to divide something by something. You don't have to. This is just an expression that means how the population changes over time.
That's misleading.
It's misleading. Well, I'm telling you about it. Okay? That, you don't have, if you see that, don't say, oh, I got to divide, I got to find something to divide. That's what kids will do. They don't know what they're talking about. This just means how the population changes. So how does the population change over time? It's the birth rate minus the death rate. B minus D. And so what was the birth rate? 1,000 per month. And what was the death rate? 200 per month. This is, by the way, you got to show your work when you do these problems. So you have to write this stuff. Don't just write an answer. Some of you just like to write answers. Question? You didn't get a sheet? Who was in charge of passing the sheets around?
Andrew.
Oh,
Of course it was Andrew.
Andrew.
Oh gosh.
All right.
How's it over there?
So, what's 1,000 minus 200?
800.
800 is the answer. dn/dt equals 800. The change in the population over the change in time equals 800. And another thing you need to understand about these equations, the sign, you got to figure in the sign. If you get a positive number here, which we do, that means the population goes up. If you get a negative number, that means the population goes down. So keep the signs. If this was, think about this, if this was 200 born per month, and 1,000 die per month, what would our number be? It wouldn't be plus 800.
Negative 800.
It'd be minus 800, and your population would then be going down. The change in population over time is negative. So if the population started, let's go back to what it actually was in the question. 1,200. If the so it's plus 800. If the population started at 2,000, what would the population be after the month?
2,800.
It would be 2,800. You got to add 800 to the 2,000 that already exists, and it goes up to 2,800. That would be the new population of mice. That's a lot of mice.
Is that the per capita growth rate of mice in Finland?
The per capita growth rate of mice is figured by a different equation. This right here. When they're talking about growth rate, they're talking about a number called R max. So now we have to use this equation to come up with the per capita growth rate. It's dn dt, the change in the number over time, equals R max times n, which is the population. So we already figured out the change in the population over time. We already figured out dn dt. What was it for this problem?
800.
It was 800. So we got plus 800 here. And what was our population to start with?
2,000.
It was 2,000. There were 2,000 mice, and it went up 800. So now you can figure your R max. How do you figure out your R max? You divide both sides by 2,000. So 800 divided by 2,000, that would cancel this 2,000 out. And R max would be 800 divided by 2,000. Is this in the way? Does anyone know what 800 divided by 2,000 is? State championship math?
0.4.
0.4. The R max is 0.4. Now let's try to figure out what that means. What does an R max of 0.4 mean?
It grows 40% a month.
It's like a 40% growth rate. It's basically saying that every mouse out there will have 0.4 new mice.
Wait, wouldn't it be 1.4? New mice?
No, it'd be 0.4. So if each mouse, there's 2,000 mice, if each one had 0.4 mice extra, if each mouse could add 0.4 mice to the population, you would end up with 800 new mice. Does that make sense? And yes, that would cause a growth to the population.
Wait,
And
so
it
what's
would
the
go from
0.4?
2,000 to 2,800. 0.4 is the R max. $800 divided by 2,000. You usually see R maxes as decimal points, but not necessarily. Yeah.
So if we're writing our answer for this one, would you want 0.4 or 40%?
Either 0.4 per capita growth rate. 0.4.
And then
Yeah,
the
0.4.
net population growth is plus 800.
The net population growth is plus 800. Make sense? Okay, so try number 2. Try number 2, and then I'll tell you the answer in about 3 minutes.
It's a lot of minutes.
2 quickly, you can go on to number 3. You're going to have to hand this in. It's going to be a quiz grade. You need to be working it on a separate sheet to hand it in. I'm not going to take it on the... Yeah.
Yeah.
No, you try to read this Make sure you show your work. Have you finished number 2? Yes.
What? Yeah, let me pull that math.
It won't last forever, will it? It could last for 1 month, but it couldn't last forever.
So
Yeah.
Willis,
Yes.
if no one is generous enough to offer paper, can we do it on the back of the paper?
No, you gotta get other paper.
Oh. More truth dead.
All right. Did y'all finish?
Yeah.
Let me show you the answer.
I'll take it.
So for number 2, how many born each month? 1,000 born in the month. How many died in number 2? 1,200 died. If 1,000 were born but 1,200 died, you'd have a net change of minus 200. That's what D and DT is. But what's the R max?
Try to divide it by the 2,000.
dn dt, which we know is negative 200, is equal to R max times n. So we plug in negative 200 here, R max times, what was n?
2,000.
2,000. And it's just a simple math problem then. R max will equal what? Anyone get it? Negative 0.1. That means the population is going down. You ever see negative R max? The population is going down. Poor mice. Maybe they introduced some cats to the field. Maybe that's what's happening.
Ran until we stopped cooking.
His name was
His
Remy.
name is Remy.
Yeah.
Number 3 is a real world example. And by the way, it says Lower Kenya. That's supposed to be South Africa. It's confusing the way it's written. It should be South Africa for both. This was taken from a longer problem that said Lower Kenya and another part of the problem. Do you know why the number of elephants are going down?
Coaching.
I want that first.
Hello?
Did you know that there's a tuskless species of elephant that's evolved?
What does a tusk do for the elephants?
Fighting.
The elephants like fight over it. It's in the males, and they use it to get mates. It's like a sexual selection. The females like the ones with the big tusks, and they use it to kind of battle, push one another around. But since the poachers are killing the ones with the bigger tusks, then they're dying out, and only the smaller tusks are surviving. And so there's these tuskless elephants that have turned up, and they don't get poached, so their numbers go up. Isn't that interesting?
Sounds like something we learned in the last chapter.
Hey, y'all, we're going to continue this tomorrow. There's going to be a quiz over this section tomorrow. I'll show you how to do the logistic problems tomorrow. And we'll leave my wife us.
Willis out.
Oh, Willis out.